ABC is an isosceles triangle with a right angle at B. The points D, E and F are the midpoints of the line segments AC, AB and BC respectively. There are 3 parts to this question. Part 1 asks us which of the given planes is an orthonormal coordinate plane. Part 2 asks us which of the following planes is an orthogonal but not an orthonormal coordinate plane. And Part 3 asks us which of the following planes is an oblique coordinate plane. So let's look at Part 1. Which of the following planes is an orthonormal coordinate plane? Is it option A, AED, option B, BCE, option C, plane BFE, option D, ABC, or option E, plane CAB? To answer this, we recall that when defining a coordinate plane OIJ, the first point given is the origin of the coordinate plane. The line from the origin through the second point, that is the line OI, forms the x-axis, and the line from the origin through the third point, that is the line OJ, forms the y-axis. In Part 1 we're looking for an orthonormal coordinate plane, that's one where the 2 axes are perpendicular, and the length from the origin to the points I and J, that is the unit lengths, are equal. So let's begin by going through each of the given options to see which satisfy the perpendicularity criterion. In option A, our origin is the point A. The axes are the lines AE and AD, but since our triangle ABC is right at angle B, then angle DAB cannot be a right angle. It must be less than 90 degrees, and therefore our axes cannot be perpendicular, and so we can eliminate option A. In option B, B is the origin, and the axes are BC and BE. And since our triangle ABC has a right angle at B, then the 2 axes BC and BE are indeed perpendicular. So the first criteria, that's the perpendicularity criteria, is satisfied for option B. Since our triangle ABC is isosceles, however, the unit lengths BC and BE are not equal. The side lengths BA and BC are equal, however BE is only half of the length of BA, and that is half of the length of BC. And since our unit lengths are not equal, we can eliminate option B. Now considering option C, again we have B as the origin. Our axes in this case are BF and BE, and we see then since B is the origin, our axes are perpendicular, and so our first criteria is satisfied. Now since F and E are the midpoints of BC and BA respectively, and the triangle is isosceles, we know that side lengths BA and BC are the same. We have BE is equal to 1 over 2 BA, BF is a half BC, and these are equal. And so for option C, our second criteria is also satisfied. The unit lengths are equal, and so the coordinate plane defined in option C is an orthonormal coordinate plane. If we look at our remaining options, that's D and E, in option D the origin is at the point A, so as with option A we can discount this, since the angle at A is not a right angle and hence the axes are not perpendicular. That is, the axes AB and AC are not perpendicular. And finally in option E we have C as the origin. The axes are CA and CB, and so the angle between them cannot be 90 degrees. The axes are not perpendicular, hence we can discount option E. And hence the answer to part 1 of the question, which of the planes is orthonormal, is option C, that's the plane BFE. Now moving on to part 2, which of the following planes is an orthogonal but not an orthonormal coordinate plane? Option A, plane BFE, option B, plane BCA, option C, plane DBC, option D, plane ABC, or option E, plane BFA. Now in an orthogonal plane, the axes are perpendicular, but since the plane we're looking for is not orthonormal, then our unit lengths will not be equal. So let's consider our 5 options. Options A, B and E have B as the origin. Option A has axes BF and BE, and these are indeed perpendicular, so the first criteria is satisfied. Option B has axes BC and BA, and these are perpendicular, so option B satisfies the first criteria. And option E has axes BF and BA. These also are perpendicular, so our first condition of perpendicularity is satisfied for option E also. Now option C has D as the origin, and since our triangle ABC is isosceles, the point D is the perpendicular bisector of AC. And this means that our axes DB and DC are indeed perpendicular. So the axes for option C are perpendicular. Now considering option D, we see that the origin is the point A. With axes AB and AC, we know that the angle between them cannot be 90 degrees. And so in this case we can eliminate option D. So we still have options A, B, C and E to consider. We know that we don't want our unit lengths to be the same, so that our coordinate plane is not an orthonormal coordinate plane. So let's look at these for our remaining options. In option A, the unit lengths are BF and BE. Now BF is the midpoint of BC, so BF is 1/2 BC, and BE is the midpoint of BA, so BE is 1/2 of BA. But since our triangle ABC is an isosceles triangle, BA is equal to BC, so 1/2 BC is 1/2 BA. And this means that BF is indeed equal to BE. This means that the unit lengths for option A are equal, so we can eliminate option A. In fact, by the same logic, we can eliminate option B, since sides BA and BC are the equal sides of an isosceles triangle, so option B does not satisfy our second criteria, and we can eliminate option B. Next, looking at option C, our unit lengths are the lengths DB and DC. And if we consider our triangles, triangle ABC is isosceles, so angle BAC is equal to angle BCA, and that's 45 degrees. And since the line segment DB bisects the angle ABC, which is 90 degrees, we have angle CBD is 90/2, and that's 45 degrees. So now we're looking at triangle BCD, and this is also an isosceles triangle. And so the side lengths DB and DC are in fact equal. This means that the unit lengths for option C are equal. Hence we can eliminate option C, since option C represents an orthonormal coordinate plane. So now finally considering option E, we have B as our origin and axes BF and BA, and we know already that BF is actually 1/2 of BA, since BA is the same as BC, and F is the midpoint of BC. So for option E, our unit lengths are not the same, and the plane represented by E is not orthonormal, but it is orthogonal. So the answer to part 2 is option E, the plane BFA. So now let's look at part 3. This asks us which of the following planes is an oblique coordinate plane. Option A, plane DBC, option B, plane BCD, option C, plane BCA, option D, plane DBA, or option E, plane EBD. So we're looking for an oblique coordinate plane, that is a coordinate plane whose axes are not perpendicular. We see option A has its origin at the point D, its axes are DB and DC, and we've seen already that these are actually perpendicular. So we can eliminate option A. For option B, on the other hand, the origin is at B, and the axes are BC and BD, and we've seen already that the angle between these two is not 90 degrees. Hence the axes for option B are not perpendicular. So B does represent an oblique coordinate plane. Option C has its origin at B, with axes BC and BA, and these are perpendicular, so we can eliminate option C. Option D has its origin at D, and has axes DB and DA, which are perpendicular, so we can eliminate option D. And finally, option E has its origin at point E, and axes EB and ED. And since these axes are perpendicular, we can eliminate option E. And of our options, only plane B is an oblique coordinate plane. Our answer to part 1 is option C, plane BFE. Our answer for part 2 is option E, that's plane BFA. And our answer to part 3 is option B, and that's plane BCD.